One of the greatest theories about space and the universe, the dark energy theory, can be completely thrown out. The dark energy theory was a result of Albert Einstein's equations of general relativity in 1917. In 1917, Albert Einstein was faced with a puzzle. The equations of general relativity showed that gravity should pull the universe inward, causing it to collapse. But astronomers at the time believed that the universe was static. It was neither expanding nor contracting. To make the mathematics fit the observations, Einstein came up with a theoretical factor he called the cosmological constant. This invisible force counteracted gravity and kept the universe in perfect balance. However, when Edwin Hubble discovered that the universe was not static but was expanding, Einstein abandoned the idea, calling it his biggest mistake. Ironically, decades later, it turned out that dark energy behaved just like the cosmological constant he had thrown out. For 25 years, it has been a fundamental part of the standard model of cosmology, which predicts that dark energy will continue to accelerate the universe forever. A feature of quantum theory developed in 1955 predicts that empty space is bubbling with energy, producing a repulsive force like Einstein's fitting factor. For the last quarter century, this constant has been part of the standard model of cosmology. The model describes a universe composed of 5% atomic matter, 25% dark matter, and 70% dark energy, born in a giant spark known as the Big Bang 13.8 billion years ago. But the model fails to say what dark matter, or dark energy, actually is. Then, in 1998, two teams of astronomers made a shocking discovery. They were studying distant supernovae and expected to confirm that the expansion of the universe was slowing down. Instead, they found the opposite. The universe was accelerating. Something unseen was pushing the galaxies apart. An unknown force called dark energy, a force so mysterious that it makes up nearly 70% of the universe, and we don't even know what it really is. But now, an international team of astronomers has discovered that Hubble was wrong. It has provided the most compelling evidence yet that dark energy is not some mysterious constant force of nature pushing our universe to expand faster and faster, but rather a force that can wane, rise, or even disappear over cosmic time. A team of astronomers, using the Dark Energy Spectroscopic Instrument, or DESI, analyzed the largest dataset of galaxies ever collected, more than 15 million celestial bodies. When they compared their findings to existing models, they found something strange. The numbers didn't quite add up. Their data suggests that dark energy may not be constant at all, but dynamic and changing over time. This means that the fate of our universe may not be what we think. If dark energy weakens over time, the expansion of the universe could slow down and eventually stop. And if gravity takes over, we could be heading for a big crunch, he said, a scenario in which the universe collapses in on itself. On the other hand, if dark energy fluctuates, the universe could go through cycles of expansion and contraction, a kind of cosmic rebirth. Astronomers on the DESI team are trying to characterize dark energy by studying galaxies at different periods of cosmic time. Small irregularities in the spread of matter in the early universe affected the distances between galaxies today. These distances have expanded measurably along with the universe. The data used for the latest DESI measurement consisted of a catalog of about 15 million galaxies and other celestial objects. The data set alone does not suggest any flaws in theoretical understanding of dark energy. But when combined with other strategies to measure the expansion of the universe, for example, exploding stars and the oldest light in the universe, spanning about 100,000 years after the Big Bang, the data no longer match what the standard model predicts. Still, the gap is a tantalizing hint that something in the cosmological model is not well understood. Scientists may need to rethink how they interpret gravity or how they make sense of the old light from the Big Bang. DESI astronomers think the problem may be the nature of dark energy. If we can establish a dynamic dark energy, the pieces of the puzzle come together better, said Mustafa Ishak Bushaki, a cosmologist at the University of Texas at Dallas, who led the latest DESI analysis. In the 1950s, astronomers argued that only two numbers were needed to explain cosmology, one for how fast the universe was expanding and one for how much the universe was slowing down, or how much the expansion was slowing down. Things changed in the 1960s with the discovery that the universe was bathed in light from the Big Bang, known as the cosmic microwave background. Measuring this background radiation allowed scientists to probe the physics of the early universe and the way galaxies formed and evolved later. As a result, the standard model of cosmology now requires 6 parameters, including the density of both ordinary and dark matter in the universe. As cosmology has become more precise, additional tensions have emerged between the predicted and measured values of these parameters, leading to numerous theoretical extensions to the standard model. But recent results from the Atacama Cosmology Telescope, the clearest maps of the cosmic microwave background to date, appear to slam the door on many of these extensions. Funded by the Department of Energy's Office of Science and managed by Lawrence Berkeley National Laboratory, DESI is an international collaboration involving 900 researchers and 70 institutions worldwide. The experiment uses a telescope at Kitt Peak in Arizona to map the history of the universe. The dataset includes 13.1 million galaxies and 1.6 million quasars, which are very bright, distant objects powered by supermassive black holes. NASA's novel Space Telescope is scheduled to launch in 2027. The SPHEREx space telescope also launched on March 11th. SPHEREx will study 450 million galaxies and discover new things about cosmic inflation and the birth of the universe. In short, dark energy and the universe are not as simple as we thought. In fact, they are much more complex and dynamic. The old idea that the universe would expand and cool is also changing. If dark energy is dynamic, the universe could collapse on itself and even rebirth. Discoveries about the birth of the universe, dark matter, and dark energy are changing what we know and understand about the universe. Thanks for watching. Don't forget to subscribe to the channel for more weird news videos. Bye.